Well, hello guys. So for the most part in these classes, I've been able to do notes just as effectively online, I feel, as we do in class, except for from this lesson. So normally when we do the notes on balancing chemical equations and working with chemical reactions, I draw a lot on the board. And I have you draw in your notes, but because I can't really draw very well on here, I am a little challenged, but I'm going to do my best. So go ahead and get out a piece of paper. You need to title it. We're going to call it 132 Lesson 1 Part 3. 132, of course, is the class number, so that way you know what this goes to, and then which lesson it's part of, so that you don't have to worry about trying to figure that out later if your picture doesn't work or something and you have to get a picture of it again. Remember to keep all these notes and activities you do because you can use them on your final exam. They can help you out. So this is notes on balancing chemical equations, and I'm going to try to make this as short and sweet as I can. In class, we would practice a whole bunch on this, but because you're just watching it as a video, I don't want to torture you by making a really super long video. So I'm going to say these things, and basically you're going to need to write some stuff down in your notes. If it is blank, so like right here, there's a spot, you can basically write down first law of thermodynamics, what I've typed, and then you're going to write down what goes in this space. Of course, you can pause it and rewind as many times as you need so that you can get it, but I'll try to be really clear when I'm saying them. So the first law of thermodynamics, don't write this part down, is something that is really important in every single science that you're ever going to work on. So it means that you can't create or destroy matter. So all the matter and all the energy in the universe has been here since the Big Bang, and it'll be here until the end of the world. All of it just gets cycled and reused. So what you would write down for the first law of thermodynamics is matter and energy can't be created or destroyed. Matter and energy can't be created or destroyed. That's a really important thing to remember when doing chemical reactions because you can't create or destroy atoms or elements or anything like that when you're balancing a reaction. So this is going to be a math equation, but we're going to look at it a little, actually kind of similarly to math, right? Like if you are doing something on one side, you have to do it to the other side. And so we're going to do that here. If we have 6 hydrogens on one side, we have to figure out how to get 6 hydrogens on the other side. Otherwise, we would be creating matter. And that would be like against all the laws of physics. So what does this mean when balancing a chemical reaction? Here's what you need to write down. The number of atoms of each element, the number of atoms of each element must be the same in the reactants and the products. So that is giving you some vocabulary words that you don't know yet. One of the annoying things about science is that there's so many vocabulary words. Like kids are like, it's hard, it's hard. It's not really hard once you know how to use all the words, but learning all the words is hard because it's just so much to add to your vocabulary. So that's the first law of thermodynamics. We're going to follow that because if we broke that law of physics, then we could all just quit life because it would mean that nothing is real that we have ever observed in all of human history. But we can't do that because that's not true. So let's go ahead and look at some of these terms. Now, these two terms, I'm not going to require you to write down in your notes like this, but I want to make sure you know them. So if you don't, like you couldn't write this down as the definition of element, you're going to want to write it down right now. So it's your choice, not required, but it's a good idea if you don't remember. So an element is any substance that has only one type of atom. So if we went to that periodic table that we looked at in the last video, anything neon, hydrogen, carbon, tungsten, any of those would be considered an element. And sometimes you can have more than one atom of an element that are bonded together. But each one of these little dots that's in this picture right here, it represents an element. If we pretended to to put one of these on here, so like we were sticking these two together, we could do that and it would still be considered an element, but it wouldn't be an atom anymore because it would have more than one atom attached. So if you just have atoms that are hanging out by themselves, then we can call them an atom and an element. But usually, and this is really true when we're talking about the chemistry of biology, these things are going to be bonded together. They're going to be bonded to another one of themselves, or they're going to be bonded to another type of element. And that brings us to the compound definition. So compounds are when there's two types of atoms that are bonded together. So in this example, they're representing the different types of elements by the color of the circle and the size of the little sphere that it is. So here we have something else. We have one of these gray things attached to two of these red things. And that's how I would know if I was looking at it that it's a compound, not an element. So we're going to be using these terms a lot, and so I just wanted to get the definition for them down. All right, let's go on to the words that I really want you to write down in your notes because they're very important. So, first of all, here we have elements. So the elements are going to be represented. Remember, we have those chemical symbols. So what I want you to write down elements is you're going to write down noted by their chemical symbol. Noted by their chemical symbol. To practice this, to look at it a little bit, we're going to figure out in this chemical equation, which I don't want you to write down yet, but you can write it down later. We're going to figure out how many in this chemical equation, and the chemical equation is written in black here, how many different elements there are in it. So first of all, we see C. If you know what C is, it is carbon. If you don't know what it is, a great way to look up elements is on the website P-Table. That's the one I had in the example. You could just look up P-Table so you don't have to write periodic every time, but it has all the elements. So if you're just looking for C, you'd come over here and see that C is the element carbon. So carbon is in it. That's one element. Dang, I'm trying to find my document. Okay. O, that's a different element, and it's oxygen. So that's two different elements that we have in this equation. And we have H. H is hydrogen, so that's the third one that we have. On the other side of this, we have C, H, and O again. So we have carbon, hydrogen, and oxygen on both sides of this equation, which is good because if we suddenly had a nitrogen or something over here, we would be breaking the first law of thermodynamics and this would not work. All right, let's go back up. Okay, the number of elements in this equation is 3, right? We just looked at them. There's carbon, hydrogen, and oxygen. Even though this oxygen is hanging out over here with hydrogen and hanging out over here with carbon, it's still oxygen. It's just oxygen atoms that are stuck together into compounds. When we're talking about an atom here, we're talking about one particle of an element. So I say we have to have the same number of atoms on each side of this to follow the first law of thermodynamics. So when we do this, we would count like, okay, well, here's O, but it's O2. So that means we have 2 atoms right here of oxygen in this compound. If you don't remember the symbols for protons, neutrons, and electrons, I put them right here. So P plus because protons are positive, and 0 because neutrons are neutral, and E minus because electrons are negative. Okay, so let's go ahead and let's look at the compounds and molecules here. We might, even though we only have 3 elements, we might actually have more compounds and molecules that these are being arranged into. So our atoms are these like one little dot or one little Lego, and we're going to put those dots together, those Legos together into bigger pieces. So let's count. Compounds and molecules, remember, are multiple atoms joined together. If it's the same type, it can be a molecule, and if it's different types, it's always going to be a compound. So if you have 2 colors, we're talking about compounds, or 2 different element symbols, that's a compound, and if it's the same, then it's going to be a molecule. So down here we have O2. O2, just guess, is an example of a compound or a molecule? It's a compound. I mean, it's a molecule because it only has oxygen in it. These numbers that are out front here, we're going to mess with those in a second, but for now we're just looking at these letters and the little numbers that are next to them. So O2 is one type of substance that we have in here. We also have C6H12O6. That's a lot bigger than O2, right? 2 oxygens stuck together here. In this example, we'd have 6 carbons stuck to 12 hydrogens stuck to 6 oxygens. So this is a lot bigger. It has a lot more atoms that are made in this compound than this molecule. So that is 2, right? We have oxygen, we have C6H12O6. I'm going to tell you that's a sugar. It's called glucose. That's what this chemical is called. So now we have oxygen and glucose. We have over here H2O, which I know you already know that one, right? It's water. So here's another compound. And then we have CO2, which is 2 oxygens stuck to a carbon, or carbon dioxide. The di means 2. So we have 4 different chemicals here, 4 different compounds or molecules in this equation. Well, why is that important? Because we're taking basically the Legos on this side and we're trying to put them together into these things that are on this side of the equation. So I'm going to kind of show you guys a little bit how to do that. Okay, coefficient. So I'm sorry, this is annoying, but we have to do this way. So what you're going to need to do is you're going to write down coefficient right here, and then I'm going to go over and I'm going to show you what all of these are. So if you can fit this right here, this model, this picture on the same page as these definitions, then you can draw arrows to them, and that's what I would do. So coefficient, this is the big number before a molecule or compound. The big number before the molecule or compound. So down here, this right here is the coefficient. It's in front of carbon dioxide. Okay, why is this so important? And you can write this on the picture, or you could put it under the definition of coefficient. The coefficient tells you the number of molecules. So in this example, we don't have 1 carbon dioxide. We actually have 6 carbon dioxides. So we have 6 kind of times the rest of this. We have 6 times 1 carbon, which would be 6 carbons, and 6 times 2 oxygens, which would be 12 oxygens. Here, it's the same thing. We have 6 hydrogens, but in each water molecule, there's 2 hydrogens, so 6 times 2H, which would be 12H, and 6 times there's only 1 oxygen, so then that would be 6 oxygens. So now we actually have 12 oxygens plus 6 oxygens on this side. Okay, let's go to the other side. There's no big number right here in front of the C6H12O6 or glucose. So what that means is that there's only 1 molecule of glucose. So we don't have to multiply these little numbers by anything. Or, I mean, we would be multiplying them by 1, but 6 times 1 is still 1. So, I mean, 6 times 1 is still 6. So we don't need to do that. Okay, here we do again have to do it because it's 6 times 2 O2, or 6 times O2s. So every time we add another O2, we're adding 2 more oxygens. Every time we add another molecule here. So we would have actually 12 oxygens. And look, we have 12 oxygens right here plus 6 oxygens, just like we had 12 oxygens plus 6 oxygens on this side, and that is the same number of oxygens on both sides. You don't have to write all that down, right? You just have to write down coefficient tells us the number of atoms, the number of molecules. Then we're going to go to the subscript. The subscript is the little number, the little cute one, okay? So that's called a subscript because it's below. If it was above, it would be a superscript, but it's little, so it's a subscript. And it tells the number of atoms. So in H2O, if we drew a picture of an H2O molecule, it would be 2 hydrogens stuck to 1 oxygen. Okay, the reactants. The reactants are everything before the arrow. So in this case, the reactants are carbon dioxide and oxygen. Here's our arrow. So after that, we're going to have the products. So the products are what we're left with. So this is kind of what goes into the equation. This is what comes out of the equation. So the reactants are what go into the equation. The products are what come out of the equation, what we get at the end. Okay, the yield arrow is kind of like an equal sign, but because a lot of chemical reactions, you can't change them back very easily. Like you can't just put these ingredients together and then change them back into this without energy. We don't put quite an equal sign because you'd have to also add energy to make this work. So for this one, we have an arrow, and that just means the arrow separates the reactants from the products, or it separates the inputs. That's another word you might want to put down for reactant is input, and outputs are the products. So it just separates those. So that is the terms we're going to be using to balance a chemical equation. Let's go down, and I'm just going to show this to you really quick because I want you to kind of write down these steps. If you just pause the video right now, write down these steps, and then I have something to say after you are done pausing. Pause. Okay, so here's what I'm going to say. This is the directions. You're going to draw a line under the yield arrow. You're going to list the elements found on each side of the equation. You're going to change the coefficients until the number of each atom of each element is the same on both sides of the arrow. Okay, here's the big thing that I want to emphasize. No, you cannot change the little subscripts. Here is why. If you change oxygen, O2, into O3 to balance a chemical equation, you're actually changing oxygen gas into something called ozone, made out of the same elements, but here we only have 2 of them bonded together, and here we have 3. Ozone will kill you. It's deadly. It ruins the atmosphere. So, like, you can't just be changing the number of atoms in each compound. You have to change the number of compounds themselves. So instead of being able to just say, oh, well, I need 3 oxygens on this side and add O3, what you'd really be doing in reality is changing oxygen gas, which is breathable and essential to you for life, into ozone, which would kill you if you were breathing it in. So you can't just do that. What we have to do instead is use those coefficients in front. So if I needed 6 oxygens here, I wouldn't just make this into O6. I would actually have to put a 3 in front of the oxygen. 3 multiplied by 2 would equal 6, but now I have 3 O2s, so there would be 2 more O2s down here. Okay, let's go to an actual example of this. So we're going to do it, and I found a website that lets me kind of have this like a chalkboard, although my handwriting is absolutely atrocious on here, so forgive me. So let's go through these steps. All right, the first thing that happens is that when you get a chemical reaction, it's usually written like this, and there's no spaces. And that was one of the things that when I was in high school confused me about what I was supposed to do, is I was like, well, where am I supposed to put all these numbers? So what I do is I just put a line. I rewrite it every single time. I rewrite it in pen because if you rewrite it in pen, you can't erase your pen, and then you won't be changing these little numbers because remember, you can't do that. You could die if you change those numbers. So you don't want to do that. So I put a line in front of N2, and then I put a line in front of H2, and then I would put I put equals instead of yields, but I don't know if I can go back and change it into an arrow. Okay, I'm going to change it into this type. Oh, dang. Hold on. Oh no, I clicked off of it. This is so hard. Okay, wait. Let's see here. Okay, so. Okay, I don't want it to be this. So I'm going to do this. Okay, so this is how you do an arrow if you can't insert an arrow. So anyways, and then I put my arrow right here and my NH4, and I can put a number here, but I can't change the little 4. So now what I'm going to do is I'm going to move to this marking tool, and you guys can see my really bad handwriting. I always, when I'm doing this, I'll like write it in pen and then solve it in pencil, or if I have 2 different colors, then I'll solve it in a different color because that helps me not change the elements in the equations themselves, but just change the coefficients. So we're going to draw a line like this. Ooh, see, look, that is not straight. Okay, and then we're going to come over here and we have nitrogen. Oh my goodness. Okay, on that side. And we also have nitrogen on this side. Oh my gosh. Okay, just pretend. I'm having to tell myself because I am OCD, so this N is not satisfactory to me. Okay, so then we have H. And so there's only two elements that are going to be involved in this equation, nitrogen and hydrogen. We have on this side, we're going to count the number of nitrogens on each side. So on this side, right now we have N2. There isn't a nitrogen over here, so we just have two nitrogens. On this side, we only have no number right here, so there's only one nitrogen. Okay, then let's go to the hydrogens and count those up. On this side, we have H with a little 2, so that means we have 2 hydrogens. And on this side, we have 4 hydrogens. So right now, if we leave this as is, we have created matter and destroyed it, right? We destroyed a nitrogen and we created 2 hydrogens from nowhere. So that doesn't make any sense. So that means we have to do something. We have to add numbers right here and multiply. It's kind of like you're putting these in parentheses. You know how when you put a number in front of a parenthesis, it applies, it's the distributive property to everything that's inside the parenthesis? So we can't separate N from H, so we actually have to modify this whole thing. So if we have 4 H's on this side, that's where I'm going to start. How would we get 4 H's on this side, but by multiplying something by 2? What times 2 equals 4? Ah, it is 2. I can do this kind of math. I don't know about your guys' algebra, but I could do this. Okay, so we multiplied 2 times H2, so 2 times 2 equals 4. So now I have to change this down here. I don't have this many hydrogens anymore. Okay, so I'm going to cross that out, and I'm actually going to put a 4 right there. But now my number of hydrogens on both sides is the same. So I have done well there. Okay, let me go back and I'm going to figure out about my number of nitrogens. So I can put what times 1 equals 2, right? I have 2 nitrogens on this side. I need 2 on this side. What times 1 equals 2? Then it's actually going to be 2. Okay, so this will be 2 times N, okay? So now I have, I'm going to get my other color just so you can see like each step that I'm doing. So N is now going to be 2. But remember that distributive property? Since this is also in the same paragraph, I'm just doing the distributive property. We multiplied 2 times N1, which gave us N2. But when we multiply 2 times H4, that is not going to be right anymore, right? We had H4 on both sides, but now we have 2 times H4, which is going to be 8 on the side. So now this isn't right. We can't have this. Now we have the nitrogens correct, but we don't have the hydrogens correct. So we have to do one more step, and I have this little erasing tool. Let's see here if I can. I'm going to change the number that's right here. Oh my goodness, wow. I really like chalkboards better. Okay, so we can't put that 2 right there anymore. We're going to have to come up with something else that times 2 equals 8. So is there something times 2 that equals 8? This is algebra, you're just doing it in your head. There is, right? It's 4. I like it when it's easy. So I'm going to put a 4 right here. And then this is going to be the distributive property times that H2, and that will give me 8 on this side. So now I have 2 nitrogens on each side and 8 hydrogens on each side, and that means that I have solved this chemical equation. There's no number right here before the N2, so just to show me that you've solved it correctly, you're just going to put a 1 there, just so that I know you didn't forget about it. Don't put a 0, right? Because 0 would be 0 times N2, which would be no nitrogen gas at all, and that won't work for this. So really what we've done is we've taken nitrogen gas and hydrogen gas, we've rearranged those Legos to put it together into something called NH4, and that is what our products are in this equation. All right, guys, that is all I have for you in this 24-minute video. Take it in two goes at least.